everyone. Hi, Chem teachers. Today we're going to talk about Bellwork to start our nuclear reactions unit and how we can start class to make our class run smoother and have our students have predictable beginnings to their class times. So for nuclear reaction, here are 4 examples of Bellwork questions that I've used in my classroom to help check for students' understanding, check for easy misconceptions that students have, and make sure that my students are ready to move on to the next part of the unit. So nuclear reactions, I like to start by having students fill in the missing particle. And you can see here that I have them just one missing particle. I don't have any extra coefficients. I'm just checking, do they understand it? And I'm using my nuclear particles that I've been using regularly at this point and ones that they have access to. I don't make them memorize them. I don't think that's realistic for them. It's not something that they're going to need after chemistry more than likely, and therefore they have access to them. So here, both of mine are in the products. You could make one in the reactants, but again, I'm just checking, do they understand that for the law of conservation of mass and energy, that I'm conserving my charge and I'm conserving my mass. So I'd have them do that. I do like to have one where I use an electron here. That is a great one to just make sure that they understand that. You could, like I said, you could have it be a reactant too, but I think just having 2 in the products real quick, do they get it? Do they not? So that's one that I like to use. Another type is writing nuclear reactions, but having them be given the word equation and then having them translate that. So that would be the next step is for what I would have mine do. So here, write the nuclear reaction when selenium-80 is bombarded with an alpha particle and emits a neutron. So notice that there's 2 nuclear particles in here, and we can see that we are adding one, so we're bombarding, and we are emitting, so that checks comprehension of vocabulary, and then also can they add and subtract correctly. A lot of time they try to do it in their head, and they might have some simple math errors. So those are 2 different types that you could do for nuclear reactions. Then we have our half-life calculations. So one thing that I check here, we have this one says how much of an 8-gram sample of lead-208 is left after 90 days, given its half-life of 30 days. So first we need to work on, can they figure out the number of half-lives really easily if they're given the total time and the time of the half-life. That checks their comprehension. Do I understand what a half-life is? So this is a really easy one in that pulling that we get 3, and then we're plugging it into our formula, which is they have from their notes. We have our initial amount divided by 2 to the n. If this is a formula that's not comfortable to use with your students, maybe their math isn't where you would like it to be, or it's a lower math chemistry class, you could also have them, okay, I divide by 2 3 times, so 8 divided by 2 divided by 2 divided by 2, and then they would get the same answer. So again, this one is set up to make sure that they understand that the total time divided by the time of the half-life is 3. That's the main objective that I'm checking here. And then in my next one, now I have a little bit of a different situation. So I'm looking for the half-life of terbium. So I'm trying to find half-life, and that's my ultimate goal. If a 20 or 200 gram sample decays to 25 in my total time. So the other way of calculating the number of half-lives. So we are kind of going backwards of the first one. So you could have your students use the natural log rules to figure out the number of half-lives. I'm going to guess that many of our students are not here yet, depending upon where they are in the school year, and where you're at in terms of just what level your students are. Are you comfortable doing natural logs with your students, or maybe that is just too much? Then again, have them just divide by 2, divide by 2, divide by 2 to get to their final mass amount. Then they see I've divided by 2 3 times. Now I get my number of half-lives to be 3. And then for our equation for half-life, now another fun fact with this one, we're solving for something on the bottom, so we have to bring that up. Depending upon, again, how your math department does it, do they rearrange the formula? Do they rearrange their variables first and then plug in? Or do they plug in their numbers and then solve for the variable. Again, use whatever is consistent for your students and the math teacher that most of them have. That's going to make your life teaching chemistry so much easier. If you're really against however they do it, have a conversation with the math department and work together. But this math of whether they substitute in first or later, it's just not worth your time. We care about the chemistry and the skills. So talk to them, do what they do for math, and then use that in your classroom. So here are, like I said, 4 different types of calculations that I use for Bellwork to make the beginning 5 minutes of my class run smoothly and have predictable beginnings to class for my students. If this video was helpful for you, please feel free to subscribe. That would be great. Like the video, and to follow us me on Facebook and Instagram. I'm at ChemEd Solutions, and I have weekly teacher tips, tricks, and resources that I would love to share with you. I email my subscribers once a week on usually Tuesdays at lunchtime. So to get on that, you can join at chemedsolutions.com/skills-focused chemistry. There, I'm going to have a freebie that has great information about how to have a skills-focused chemistry classroom and get you some other great resources for free as my gift to you for subscribing. And then you'll get free weekly newsletters with great information to help you have a better life teaching chemistry, take less work home, and have more time for you. So with all that, thanks for watching and happy sciencing.